Welcome to Everything Steam. I'm your host, Sam Stanford. This episode is a special edition of Everything Steam featuring a brief interview with one of the tour guides at the Meteor crater in Barringer Space Museum. Now, apparently I wasn't cool enough to get a backstage pass away from the crowd. So bear in mind, this interview took place during open hours, so there will be a fair amount of background noise going on. But just in case that the background noise is too much and you miss some of the juicy details, be sure to stick around after the interview because I take about 4 minutes just to summarize what was said. So with that, I hope you enjoyed this interesting special edition of Everything Steam, featuring one of the most preserved and historic impact zones on Earth. Hey there, I'm here with Jeremy from the Meteor crater Barringer and Space Museum. I wanted to start off by maybe talking about the Barringer crater because it has high significance within the science community because it was a revelation of time. So Jeremy, what are some of the numbers and what really happened here at the Barringer crater?
So, what is said to be the meteorite traveling from space, an asteroid at weighing over 300,000 tons, traveling 26,000 miles an hour through space. When it reached our atmosphere, about 20% or more had been disintegrated on point of entry. When it did make impact, it had the force of a 20 megaton bomb. When it made impact, the meteorite itself, being 150 feet in diameter and 150 feet in length, was disintegrated and burned into the Earth's surface, as well as exploding in debris 30 miles out in each direction. At the same time, the same event occurring of what you would see an atomic bomb. A mushroom cloud going up, shooting 40 miles, could be seen at least 40 miles in each direction. Again, wind and debris pushing 30 miles out, 400 miles an hour at least. Debris, wind, picking up. Debris here is molten rock as well as meteor fragments from impact. The explosion and force could be felt through the ground about 800 miles, all in each direction. When impact first happened, the crater was said to be at least 1,300 feet in depth. And then over a time period of when the natural occurrence happened and filled after the explosion had happened, naturally filling the hole back to 700 feet. And then today is at 550 feet due to all the wind erosion pushing in about 1/8 of dirt in from the rim, filling it back in each year. Again, that's going to be at 100 or 550 feet in depth today. It's 4,000 feet in diameter, which is 2.5 miles all the way around and a mile across.
So this is really interesting, especially because this is one of the most preserved impact craters on Earth. So it's highly studied, especially over the years. Am I right by saying that?
It's one of the most preserved areas due to the fact that we don't get much moisture in this area. The most moisture we get is during our monsoon season, which happens, I believe, July through September. And we only get about 5 inches in this area. So that's about a good hour shower at most. But it's still enough in this area to keep this well preserved due to the fact that once it gets wet in here, the sun and the dryness of this area all mix and works together with the wind, preserving it and keeping it nice and solid to where it hasn't really changed as much over the years. Because I've been here during the 90s and it still looks the same other than buildings being represented here or new attractions as well.
Right, because typically, like you were saying, there's, erosion. Earth undergoes erosion. If you look at the moon, the craters on the moon have been there since their impact. But this is a special case, whereas most craters will typically fill due to wind and water erosion, and then you'll get more of it's like a soup bowl effect where then, an ecosystem kind of takes back over the area.
Yeah.
Now, take a step forward here and talk about the significance and the findings. Maybe we could talk about the findings first. What did they find here that was definitive, that showed that it was actually an impact? Because at the time, like what you were saying in the tour, that this was believed as a volcanic vent, right?
A volcanic steam vent.
What
they found in the early 60s was actually 2 minerals known as coesite and stichibite. These are forms of what we know today as shock quartz crystals. It takes crystals 1.4 million pounds of pressure at least to make, and 700 to 1,500 degrees of heat. When he found these here, they were made all the way in the bottom of the crater. At the bottom of the crater is found metamorphic rock, as well as shock rock, meaning these rocks can only be made under intense heat and pressure. And with this being down there, this metamorphic rock showed that it was only intensely put under heat and pressure there, symbolizing two findings that this place actually had together, which was Mr. Barringer's findings of those, but it being Eugene Shoemaker's findings. When he did find these two, it helped solidify the evidence that there was no volcanic activity here, other than one piece of mineral finding in this area due to a volcano explosion happening millions of years ago. And that piece of mineral they found here that was volcanic being cellulite, having that spread out in each direction,
Right.
no matter how far you could possibly think. A volcano could go no matter impossible directions. But they finding that piece here, making that somewhat tied into the volcano theories as well, other than it being branched off a volcanic site, being a volcanic steam vent today.
Right, and it also makes sense because there's no fault line right here at this area. If there was, you would see more of high abundance of igneous rock. We see a high abundance of sedimentary rocks.
Yes.
Right. Let's talk about the stratigraphy of the impact, if you don't mind.
All right, so we have 3 different surface layers on our desert floor today. The top surface layer is 250 million years old. That's Montcopy red sandstone. And then you have the next surface layer, our middle surface layer, which is known mainly widely in this area because of the Grand Canyon. That is because of the Kaibab limestone. That being the Kaibab trails in the Grand Canyon. That's 270 million year old rock right there, also known as fossil rock. And then you have the bottom surface layer being white coconino sandstone, which is 280 million years old, being the bottom surface layer. When this impact happened, the 20 megaton bomb force actually excavated and moved 180 million tons all in a matter of 10 seconds, flipping and rolling it up the crater wall. And then right on top of that, with all this all happening, raising the strata, the desert floor, up, and then on top of that, a reverse stratigraphy happening process. That is the overturning of layers, surfaces, all in once. Taking those 3 surface layers and actually flipping them like a pancake, but like a door hinge, perfectly over on one another. Again, making it not just 3 anymore, but 6, just in reverse of each other. Again, starting from the top of our rim today, you would see it going in from the white coconino sandstone being the top rim, and then slightly hints of the yellow kaibab, and then not 1 but 2 layers of the Montcopy red sandstone, and then after that, originally going back into the layout of yellow kaibab into white coconino sandstone into the bottom of the crater.
So we're recapping here, and the significance of the Barringer crater is not only because it's perfectly preserved in an aspect of what typically happens with impact areas, but also the scientific significance of this between the reversal of stratigraphy, the shock minerals, and then also the abundance of metamorphic rocks in the basin of the impact zone. We're able to now more quickly identify impact craters, impact areas than we did in the past. And I think that there's more amazing work that's to come here. As you mentioned, they're looking at the angle of which it came into the zone, and then also trying to get a better understanding of the meteors or et cetera that's in abundance in our solar system, because this is a piece of evidence that came from the formation of our solar system, something that's 4.6 billion years old in our backyard that we can kind of study.
It's always something new that happens. Like I said, research is continuing. They're looking to at least add on at least 10 or 11,000 more years onto this, looking to make it 60 to 61,000 years. So there's still more evidence still coming up.
That's amazing.
So there's still more out there. I was talking to you during the tour about NASA. NASA actually has plans on coming back here again within the next 5 years.
Okay.
This project being the next moon and the largest moon mission going out today. It's
Artemis.
called Artemis Project.
Nice.
They're actually going to be coming back here and doing training again for that same project. So we won't be closing. We'll actually be open for the public. We want people to see this just so that they see that NASA does actually get involved with this area, or is actually somewhat in partners with this place. But that project and many more will actually be set foot on not only craters like this, but all around areas. They're looking on going into the Mars, or I think it was Mars, and looking to go into next. And the craters that they're looking on studying and actually going to there, located in Antarctica. Because again, they want to train in the same area, in the same environment that they're going to, a place with no sustainable life.
Right.
So that's why they want to go to the craters in Antarctica today and do those. So there's pretty much more going on. We just haven't really heard of it yet. But if you do look into it more, you'll see this place coming up and showing up a lot more into this future as well.
That's awesome. Well, thanks, Jeremy.
Yeah, no problem.
Appreciate it.
The rest of your day.
You too. Thanks. I hope you enjoyed the episode. Again, my apologies for the background noise. So just in case you missed some of the juicy details that were tossed out during the interview, I thought I would just take a minute and summarize for you. So this impact happened roughly 50,000 plus years ago in present-day Winslow, Arizona. The meteorite weighed about 300,000 tons and traveled at a speed of 26,000 miles per hour. And when it struck the Earth, it exploded with a force of 2.5 million tons of TNT, or about 150 times the force of the atomic bomb that destroyed Hiroshima. And most of the meteorite was melted by the force of the impact and spread across the landscape in a very fine, nearly atomized mist of molten metal. Millions of tons of limestone and sandstone were blasted out of the crater, covering the ground for probably about a mile in every direction, with a blanket of shattered, pulverized, and partially melted rock mixed with fragments of meteoritic iron. And then in the early 1900s, American geologist Daniel Barringer, he bought what was originally dubbed by the science community as a volcanic vent, so they didn't even think this was an impact crater at the time. But Mr. Barringer was adamant that this was an impact site. And after decades of searching and research behind this, in the 1960s, researchers discovered that some pieces of the ejected sandstone contained microscopic evidence of intense impact pressures. Within the individual quartz grains, researchers saw crisscrossing sets of parallel lines, and these lines show that intense pressure passed through the rock in a fraction of a second, altering the grain's three-dimensional crystalline structure. So this finding then changed how the scientific community identified impact zones, effectively changing how science looked at craters on Earth. So the major signs they found were the shocked minerals, but then they also had the evidence of reverse stratigraphy, or the overturning of the rock layers in the impact area, kind of like a hinging effect. And from good old geology class, that reverse stratigraphy is an event-driven phenomenon, as well as the metamorphic rock in a bed of sedimentary rock. Right? For your information, if you don't know what metamorphic rock is, it is rock that is formed by intense heat and pressure, and it was absolutely uncharacteristic for it to be in the location that it was. Like random metamorphic rock in 280 million year old layers of sandstone and limestone. Raises kind of a big red flag, you know? These instances fully proved that this indeed was an impact crater. And the neat thing is that there's so much more history here at the crater than you think. There's 3 films that were shot here in the past. NASA used this crater for their famous Apollo missions training. And the rich history of Mr. Barringer's story there is enough to make you want to go learn more. So if you like space, geology, earth science, or if you just love sightseeing and history, I highly recommend you go check out the Meteor Crater and Barringer Space Museum in Winslow, Arizona to see the crater for yourself and learn more about the science of impacts. And just a quick tip, I highly recommend that you go see the site whenever NASA is back at the crater. They plan to train their astronauts for the Artemis missions. So stay tuned for any updates on that. We will be sure to post that on our socials. And if you enjoyed this special episode, leave us a rating wherever you get your podcast from, and be sure to lend us a hand by sharing our show with your friends, your family, acquaintances, or heck, even your enemies. Once again, thank you for listening to this special edition of Everything STEAM. I am your host, Sam Stanford, and as always, stay curious.